Hey guys, for this test review, I hope that you printed out the attached assignment or the review sheet, I guess, and attempted these on your own. And if you get stuck or you don't know what to do, then watch this video. But I'm just going to work through four geometry proofs, so two triangle congruency proofs, and then two proofs proving that some corresponding parts are congruent. And these are actually examples that we did do in class, so I apologize if you noticed the repetition. But these are the ones that I have for you, so let's get to work here. So here's the first proof. We're given this diagram here, and we're given that this side AD is parallel to this side BC, and also we know that they're congruent to each other. And our job is to prove that this triangle AED right here is congruent to this triangle BEC right here. Okay? So that's what we need to do. Now, to prove triangle congruency, what we need to do is prove a triangle congruence combination. So show that one of these exists. Maybe like we know that all three sides in both triangles are congruent. Maybe we know that two sides are congruent and an angle in between the two sides. Maybe we know that we have two angles that are congruent in the triangles and a side that's not in between the two angles, known as angle-angle side. Or maybe we know that we have two angles and a side in between them that are congruent, right? So these are our triangle congruency combinations, and that's what we need to see if we can actually build and argue that one of these is true, and that forces our two triangles then to be congruent. Okay, so for our proof, we always write the given, so I'm going to say that AD is parallel to BC. Also, we don't have to put it in two lines, we can put this all in one line. AD is congruent to CB. And I'm going to move these guys over here. Okay, so the reason that we can say that is because it was given to us, right? We look at this picture, it's some given facts, some given information that we know we can work with when it comes to this diagram. So we're given a side already, right? We already know that those sides are congruent. So we're, again, trying to build one of these congruency combinations right here. So we have a side congruence in both triangles that we're trying to prove, all right? Now, whenever I look at pictures like this, my eye goes to these intersecting lines right here and here, right? So when lines intersect, the vertical angles that are across from each other, are always going to be congruent. We proved that in class, and because we proved it, there's a theorem that states that when two lines intersect, angles across from each other, known as vertical angles, are always going to be congruent. So what that means then is we can say that angle, the left angle, we have to use a 3-point labeling system, which is angle, I'm going to call it angle AED, has to be congruent to its vertical angle, the right angle, which I'll call angle BEC. And the reason for that is we can just say vertical, so I'm going to do vert for short, angle, and do my angle symbol, vertical angles theorem, and for short for theorem, THM. So the vertical angles theorem says that those two vertical angles have to be congruent. So now, for our triangle congruency combination, we have a side and an angle. Okay? So that's nice. We just need to find a third part then and see if it's one of these combinations. So now let's use the fact that the two sides are parallel, right? So when it comes to parallel lines, you guys have to be able to recognize that if this side AD, and I can extend it too, right? If this side AD is parallel to this side BC, then one of these diagonals can be thought of as a transversal, maybe this one, right? So if we have parallel lines and a transversal, one thing that we know is that alternate interior angles are congruent to each other. So this angle that's inside the two parallel lines and alternate sides of that diagonal are called alternate interior angles. They have to be congruent. That's just it's a geometric fact that we've been working with. So we need to identify those angles in those triangles are really congruent to each other. So then we can say the angle, to label this angle right here, it would be angle ADE is congruent to angle we'll say this angle up here would be like CBE. And the reason for that is we have alternate, so ALT for short, interior, INT for short, angles theorem. And the theorem says if lines are parallel, then the alternate interior angles are congruent to each other. So we know that those angles are congruent to each other. So if you look at our triangle, we now have stated 3 congruency parts, right? So we have 2 angles and a side. The sides are not in between the 2 angles that are congruent. The side that is between would be like this one, and that's not the combination we have. The side's not between the 2 angles, so therefore we have what we call an angle-angle side. So that is enough now to go ahead and state what we wanted to state, right? That triangle AED has to be congruent to the other triangle CEB because of our angle-angle side argument that we made. And we're done. And you can end a proof if you want with the little square, and you color it in. That's the symbol of a done proof. Okay, let's go to proof number 2. Same kind of idea. We're going to prove that 2 triangles in this picture are congruent to each other. We're going to prove that triangle JKL, so this one right here, has to be congruent to this triangle MLK, which is this blue one right here. Okay, so that's what we want to show, that the red and the blue triangles are congruent to each other. What we know, what we're given, is the fact that JK is congruent to this side ML. And also this angle right here, which is an angle in this red triangle JKL, is congruent to this corresponding angle over here, which is an angle in the blue triangle MLK. So what's nice about this proof and the given information is that we're already given a side and an angle congruence pair. So we actually have 2 out of our 3 pieces that we need to argue. So there's got to be a third piece that we know. So let's first start the proof. Write the given. We know that JK is congruent to ML, which also angle JKL is congruent to angle MLK. The reason we say that is it's given to us. So that's stating that side congruence and the angle congruence. So we need that third part. And if you notice, both triangles are sharing this segment KL right here, right? So by the reflexive property, KL in, say, the red triangle has to be the exact same length as KL in the blue triangle. So to state, the reason we get to state that a segment in one triangle, when it's shared in the other triangle, the reason that they're congruent to each other is what we say is known as the reflexive property. Okay? So we have a side congruence, an angle congruence, and another side congruence, right? So now that side is congruent to itself. And if you think about, say, this red triangle here, now it's blue, we have a side, an angle, and a side, right? And over here we have the same combination. So we have enough to argue that triangle JKL is congruent to triangle MLK by our side angle side combination. And we're done. Third proof. Here we're not proving that these 2 triangles in this picture are congruent, but we're going to prove that some corresponding angles are congruent. That this angle W up here is congruent to this angle Y. Okay, so to do that, the logic is exactly like the first 2 proofs. We do have to prove that we have some congruent triangles, like this triangle up here, call it WZX, if you will, and this triangle down here, call it XYZ. We have to prove that those 2 triangles are congruent to each other. And then once we can state that they're congruent to each other, then we know that their corresponding parts then have to be congruent, because that's what it means for 2 triangles to be congruent, that all 6 corresponding parts in both triangles then have to be congruent. So let's see what we got here. So in our proof, that green may not be good. I'm going to go to blue. In our proof, we're given that all 4 sides are congruent to each other. So side WX is congruent to side XY, which is congruent to side YZ, which is congruent to side ZW, right? So all 4 of those sides are congruent. This is a rhombus, right, based off our given information. And we need to prove that those 2 angles are congruent. Okay, so the reason we get to state that again is from given information. All right, so let's prove that these two triangles are congruent, and the only thing that we don't know anything about parallel, so we can't say anything about alternate interior angles being congruent because we just don't know that we have parallel. But we do know that they share this diagonal right here, right? So we know that ZX is congruent to itself in both triangles. And again, that's just the reflexive property. Okay, so now we have, from our given, we had this side, which maybe corresponds to this side, so we have a side congruence. This side corresponds to that side, so we have two sides that are congruent, and this side corresponds to itself. So in the two triangles now, we know that they're going to be congruent to each other by a side, 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 right? All three sides in these triangles are congruent. So we can say then that triangle, and just pick a label, WXZ, must be congruent to triangle, and the point that in this red triangle that corresponds to W would be Y. I look at this as a reflection. If you fold it on that diagonal, then angle Z would correspond to itself and X would correspond to itself. So X, Z, right? So those two triangles are congruent. And now that we know that they're congruent, we know that angle W has to be congruent to angle Y. So that's what we wanted to prove. So we're going to say that angle W has to be congruent to angle Y because they're corresponding parts of congruent triangles, so they're congruent. CPCTC. Make sure that you know what CPCTC stands for and how to use it. This logic falls right after we prove triangles are congruent, because once triangles are congruent, then their corresponding parts then have to be congruent. Okay, last proof. This one says that in this diagram, M is the midpoint of both of these segments, PQ and RS. So we need to prove that the segment PS is congruent to the segment QR. So to start this proof, let's just get the givens out of the way. So we know that M is the midpoint of PQ and RS, right? Given to us. Okay, so now we don't have any just straightforward given some sides are congruent to sides or angles are congruent to angles. All we're given is that M's the midpoint. So we have to take that fact and use the definition of midpoint to do some side congruency, because midpoint is a side idea. So let's first of all tackle, since M is the midpoint of this segment PQ, what that means then is M has to be equidistant to both endpoints P and Q, which means then this half segment PM has to be congruent to this half segment MQ, right? So I'm going to go ahead and state that. PM has to be congruent to the segment MQ because that's really what the definition, so DEF, definition of midpoint means. Because M's the midpoint, we got two equal segments, right? All right, let's take the fact that M's the midpoint of this this segment right here, RS. So then, if M's the midpoint, same argument, it's the same distance from R as it is to S, therefore those segments have to have the same length. So then we know we can state that the segment RM, the half of that segment, is congruent to the other half MS. And it's the same argument, so instead of writing it, I'm just going to double quote it, which implies same thing. And then again, we have some lines intersecting here, so this vertical angle has to be congruent to that vertical angle. So we can say that angle SMP has to be congruent to its vertical angle, angle RMQ, right? Because they're vertical angles. So vert angles theorem. You don't have to write theorem. Just writing vertical angles is good enough because we know that vertical angles are congruent. So in these two triangles now, we have a side angle side argued. So we know that triangle SMP has to be congruent to triangle R would correspond to S up here, and then M corresponds to itself, and then Q, right? So those two triangles SMP has to be congruent to triangle RMQ, and we built a side angle side argument. And then the last thing again, now that we know that those two triangles are congruent to each other, then these corresponding sides have to be congruent to each other, which is what we wanted to prove, right? So we would just then finish with QR has to be congruent to the segment PS, which we say, again, they're corresponding parts of congruent triangles, so they're congruent. And we are done. We proved 4 triangle congruency proofs, including a couple that were some corresponding part proofs. So I hope that made sense. If not, come see me in the morning and we can talk through these or some extra problems to kind of get you on your way for the test. But good luck, everybody. I hope that helped.